The clock struck midnight when the diagnostic report arrived, signaling a multi-billion-dollar error that defied all logic. An automated financial algorithm, tasked with predicting market shifts, suddenly pivoted toward an irrational, non-existent asset class, hemorrhaging capital with surgical precision. It did not break, it hallucinated. This incident serves as the haunting introduction to our exploration of modern artificial intelligence. We have entrusted our infrastructures to systems that mirror human cognition, but lack the grounding of reality. When an AI creates a fact from the void, it is not simply a bug in the code, it is a fundamental property of its architecture. As we integrate these neural networks into the marrow of global systems, we must confront a terrifying truth. We have taught machines how to predict, but we have failed to teach them how to discern truth from fiction. The ghost is in the machine, and it is beginning to speak with absolute, unearned confidence. To understand the hallucination, we must dissect the transformer architecture. Unlike the rigid, rule-based programs of the past, the transformer is a probabilistic engine designed to process sequences of data by attending to relationships between disparate concepts. Think of it as a vast, multidimensional map of linguistic probability. During training, the model ingests billions of pages of human text, distilling the statistical essence of language into a complex geometric space. It does not store facts in a traditional database. It stores the likelihood that a specific word should follow another, given a specific context. This architecture is remarkably efficient at mirroring the structural fluency of human thought. However, by prioritizing fluid prediction over rigid verification, the model develops an internal logic that favors coherence over veracity. It is a brilliant mimic, constructing sentences that sound plausible even when they describe events that never happened. The model is essentially dreaming in a language we taught it. The core of the transformer's power lies in the attention mechanism, a mathematical process that assigns weights to every word in a sequence. As the model processes information, it calculates which words are most relevant to the current context, forming a web of connections that span the entire document. When a user provides a prompt, the machine scans this web, amplifying the signals that align with the user's request, while suppressing others. But here is the danger. The attention mechanism is a master of association, not validation. If a prompt is ambiguous or based on a false premise, the model's attention mechanism may lock onto statistically likely but factually incorrect patterns. It creates a feedback loop where the model convinces itself of a hallucination because it has assigned too much weight to a misleading correlation. The machine is not lying in the moral sense. It is simply following the most statistically probable path through its internal, hyper-connected dreamscape. Why do these models hallucinate? Because they operate on a fundamental bedrock of probability, not certainty. Every word generated is a gamble. The model chooses the next token based on a distribution of possibilities. And in a creative task, there is a parameter, temperature, that allows the model to select less likely outcomes to make the output more interesting. When we push this temperature higher, we encourage the model to stray from the rigid path of facts into the creative fog of synthesis. In this state, the model is essentially hallucinating on purpose to simulate human-like variety. However, this creativity is a double-edged sword. It allows for the generation of beautiful poetry, but it also opens the door to synthetic delusions. The model cannot distinguish between a creative metaphor and a factual distortion. It treats a historical biography and a work of science fiction with the same probabilistic indifference, leading to the confident articulation of blatant falsehoods. A hallucination is rarely a singular point of failure. It is often a cascade. Once the model generates a single incorrect detail, a false date, a non-existent legal case, or a fabricated person, it treats that hallucination as a truth upon which to build subsequent layers of reasoning. This is the recursive trap of large language models. Because the model relies on its previous output to generate the next segment of text, a single error pollutes the entire context window. The machine enters a state of confabulation, where it continuously justifies its initial mistake to maintain internal consistency. It is as if the AI is trapped in a distorted mirror room, where each new reflection is based on the previous distorted image. By the time the final paragraph is produced, the model has constructed a reality so coherent in its logic, yet so entirely detached from the actual world, that it appears to be the work of a sophisticated, albeit confused, mind. Is there a flicker of something more behind the hallucination? Some researchers suggest that what we call hallucination is actually a nascent form of machine intuition, a way for the model to bridge gaps in data where explicit facts are missing. Humans possess this capacity. We infer, we guess, and we often fill in the blanks using a mix of experience and creative synthesis. When an AI hallucinates, it is attempting to connect dots that are too far apart for human-curated datasets. This synthetic intuition can lead to unexpected scientific breakthroughs, where the AI suggests a chemical structure or a coding pattern that a human would never have hypothesized. However, this intuition is dangerously ungrounded. We are caught in a paradox where the very mechanisms that allow for high-level creative reasoning are the same mechanisms that allow for deep, dangerous delusions. We are balancing between an oracle that guides us and a deceiver that leads us astray. How do we bridge the divide between the machine's internal model of reality and the actual physical world? This is the current frontier of AI research. Engineers are developing retrieval-augmented generation techniques, which force the model to consult verified external databases before articulating a response. It is a desperate attempt to anchor the hallucinating mind to a tether of truth. Other researchers are implementing self-correction layers, where a secondary model acts as a critic, constantly monitoring the output of the primary model for errors. Yet, even with these safeguards, the problem persists. The nature of the transformer architecture is fundamentally geared towards linguistic fluency rather than factual accuracy. True grounding would require the AI to possess a world model, a deep understanding of physics, causality, and time that exceeds simple textual pattern recognition. Without this, the model remains a brilliant prisoner of its own statistical vocabulary, forever prone to weaving elaborate, convincing, and entirely false narratives. As we conclude our journey, we find ourselves at the edge of a new paradigm. We are no longer using machines as static tools, but as active participants in our creative and analytical processes. The ghost in the neural network is not going anywhere. It is part of the essence of these models. The question we must face is not how to eradicate machine hallucinations, but how to live with them. We must become more skeptical, more vigilant, and more discerning. We must learn to treat AI output not as gospel, but as a preliminary draft that requires our own human intervention. The future of artificial intelligence will not be defined by machines that are always right, but by our ability to manage the moments when they are elegantly, dangerously wrong. The dream of a perfect, all-knowing machine is a fantasy. The reality is a collaborative dance between the human spirit and the machine's beautiful, flawed imagination.